Hello everyone, welcome to the channel. I hope you all are doing well. Today we are going to discuss a very important three-dimensional figure, that is a cylinder. Have a look at the definition and then I will be explaining it in the three dimension. Here you can see there are few cylinders which are kept in one another. Now can you tell what are the parameters which are differentiating these cylinders from one another? By looking at the presentation, you can understand that there are two parameters, the height of the cylinder and the radius of the circle at the upper and bottom side of the cylinder. If we look at the surfaces of the cylinder, there are three surfaces a cylinder is made up of. You can see one is the lateral surface and there are two circular surfaces at the upper and bottom side of the cylinder. So area of the cylinder should be the addition of the areas of these three surfaces. Let's see two defining parameters of the cylinder, that is height. Line joining the two centers of the circles is called the height of the cylinder. Radius r of the cylinder is the radius of these circular surfaces and both the circles should have same radius. If we join any center of the circle with the circumference of the circle, that would be the radius of the cylinder. Because both the circles have same radius, so we can take any of them. That means BD and AC both can be considered as the radius of the circle. And if we join both the centers B and A of the circles, then this line BA would be considered as height of the cylinder. Being a circle, the area of upper and bottom surface would be pi r square. This blue part is the lateral surface, the area of which would be 2 pi RH. Later in this video, I will explain why we are considering the lateral surface area as 2 pi RH. First, see that total surface area should be the addition of lateral surface area and the surface area of both the circular bottoms. Lateral surface area we have considered is 2 pi RH. So the total surface area of the cylinder will be 2 pi RH plus 2 pi r square. Here you can go through what I have just elaborated. Now let's discuss the cross-section area of a cylinder. Cross-section area is, as we know, that when we cut a 3D shape into a horizontal or vertical direction, the 2D area which we get is called the cross-section area. Here you can see that we have cut the cylinder horizontally. When we cut the cylinder horizontally, you can see a 2D shape of circle appears. I have highlighted the cross-section area as the circle with center E. The horizontal cross-section area of a cylinder is a 2D shape which is a circle. And if you notice carefully, the area of this circle would be again pi r square because it is parallel to the two circular surfaces of the cylinder. So we can directly find out the cross-section area of a cylinder horizontally by the formula pi r square, where r is the radius of the cylinder itself. I hope horizontal cross-section is clear to you. Let's move on to vertical cross-section area of a cylinder itself. For a vertical cross-section area, the three-dimensional figure, which is a cylinder here, has to be cut vertically parallel to y-axis. Here you can see by vertical cross-section, you can see a two-dimensional figure is getting generated. I hope you can find it out here. Let me just highlight it. So the two-dimensional figure at the cross-section which we can see is a rectangle. In cross-section areas of a cylinder, horizontal and vertical, there is a little difference. In horizontal cross section, every time we get a circle with the same radius which is similar to the radius of the circle. But in vertical cross section, if the cross section is through the center, then dimensions of the rectangle would be different. And when the cut is apart from the center, then the dimension of that rectangle would be different. Here you can see we have cut through the center, so the dimensions of this rectangle would be, length would be the diameter of the circle and the breadth would be the height of the cylinder. But if the cut does not go through the center, it is very obvious from this presentation that the length would not be equal to the diameter of the circle. It would be less than that. But yes, the breadth would always remain the same, which is height of the cylinder. So whenever you see the questions of cylinder related to cross section area, always keep this in mind, that if at all it is given, that from where you have to consider the cut, especially in the case of vertical cross section area. For horizontal cross section area, we have no need to worry about, because every time we will get the same area, which is pi r square. So here the case what we have taken, in which the cross section is through the center, the area of the cross section would be the area of a rectangle with the sides 2r and h. In this case, even if in the question it is not given what is the length of the cross section area, we can easily find it out, because it is equal to diameter of the circle. So I hope vertical cross section is clear. So now let's move on to another topic. We know that the volume of the cylinder is pi r square h and volume of the cone is 1/3 pi r square h. If practically I want to show, then this should be the situation in which this can happen, in which we can clearly see that the radius of the circle, of the cone and the cylinder should be same, and the height of the cylinder and cone should be same. Only in that case we can say that the volume of the cone is 1/3 the volume of a cylinder. If any of the factor is different, like if radius is different or the height is different, then in that case it is not possible. I have elaborated this concept more in the separate video which I have made for the cone. So if you want to know more details about the same topic, then you can just go through the same video. Now let's move on to another fact which I told you that I will be discussing in the next part of the video, that why do we consider the lateral surface area of a cylinder as 2 pi RH. I am going to prove this through 3D representation practically. Let's look at the shape of the cylinder. We can see if we try to open it from any edge, then we can understand that this cylinder is made up of two circles, and this lateral part must be obtained from a rectangle. We must have taken a rectangle and folded it into a lateral part. Then on the upper surface and lower surface, we fixed these two circles. The area of these circular parts has no need of any discussion, because we know it would be pi r square for each of that. So let's open this lateral part. I have taken this straight line, which is a vertical line DC, and I am going to open this cylinder, after which I will be getting a rectangle, so that if I want to get my cylinder again, I will just fold it and get the cylinder again. Here you can see I have opened the cylinder's lateral area. I have not removed the cylinder, so that you can understand that after folding again I can have the cylinder back. So now the question is, what is the area of this rectangle? Because the area of this rectangle is actually equal to the area of the lateral surface. Length DE of the rectangle is equal to the circumference of the circle, which is equal to 2 pi r. Breadth EH is equal to height of the cylinder. So area is 2 pi r into h, which is the area of the rectangle, also the lateral surface area of the cylinder. So from here we find out the lateral surface area, which is equal to 2 pi RH. Here you can go through the formulas, and let's move on to next topic, which is hollow cylinder. This is the definition. As the name suggests, it is hollow or empty inside, and it has some difference in between inner radius and outer radius. So if we look at the circular surfaces, so circular surfaces are made up of two circles. One is called inner circle and another is outer one. Here the yellow one is outer circle and the purple one at the bottom side is inner circle. Let's say the inner and outer radius are small r and capital R respectively. Because it is hollow and there is a difference between inner and outer radius, there is always some width, which is capital R minus small r. For volume, first we find out the volume with respect to outer radius, then with respect to inner radius, and then subtract. And for surface area, we add both the surface areas of inner and outer surfaces. And for total surface area, we add to this the circular surface area also, which is pi capital R square minus small r square, because rest part is hollow. Examples of hollow cylinders are pipes, straws, etc. I really hope this video was helpful for you. Thank you so much for watching. Bye bye.